All right, now we're going to do this is spring final review. And we're going to do number 9 through 16. And we are reviewing adding, subtracting, multiplying, and dividing rational expressions. And once again, rational expressions are fractions. And these fractions happen to contain polynomials. So 5y squared times 12, 5y squared over 4y times 12 over y is your first problem. Now, when you multiply fractions, you multiply straight across and simplify. So here's what I'm going to do. I'm going to multiply straight across. Remember, you don't need a common denominator. That's for adding and subtracting. Now, do you see any addition or subtraction signs? I don't. That means this is a monomial and this is a monomial. This is all multiplication, so we can just break it apart, factor it so easily. And what I'm going to do now is cancel out my common factors of, got a 4 here, a 4 here. I have a y here and a y here. And I have a y here and a y here. And let's see what I'm left with. 5 times 3 in my numerator is 15. Remember, when you're canceling these out, you're actually leaving behind little ones. So 1 times 1 times 1 is 1. Simplifies to 15. Okay, number 10. 7x over 3 plus 5x over 3. Okay. Adding fractions, common denominator. I have one, so that's my common denominator. So now I'm going to add my numerators. And when I add these are like terms, so I get 12x over 3. Monomial, monomial. Break it apart, baby. Boom, boom. I'm left with 4x. Make sure you know that that 4x is in the numerator. There's a 1 in the denominator, and that simplifies to 4x. 11, 3x plus 18 over 4 times 8x over 2x plus 12. Multiply. Don't need a common denominator. That's for adding and subtracting. Multiplying fractions. Give it a try. Multiply straight across. So here's what I'm going to do. I'm going to multiply 3x plus 18 times 8x. And then I'm going to multiply 4 times 2x plus 12. Now, I could multiply these together and get a big fat polynomial and then factor it, but look at what else I can do. This is a polynomial. If I factor this, I look for a GCF. My GCF is 3. So I have 3 times x plus 6. And don't forget, I have my 8x here also. And you know what? Well, let's just do that for now. I have 4 here. This is a polynomial, so I'm going to look for a GCF, which is 2 times x plus 6. So I still have 3x plus 18 times 8x, and I still have 4 times 2x plus 12. Oopsie, this is a 6, not a 16. All right, look at what we have here, guys. I have a factor of x plus 6. I have a factor of x plus 6. I don't see anything else that I can cancel out, but I can still do some factoring. So I have a 3 times 8. Instead of 8, I'm going to write 4 times 2 times x. That's what's left in my numerator. 3 times 8 times x. And in my denominator, I have 4 times 2. Oh my goodness gracious. Sweet. In my numerator, I'm left with 3 times x times 1 is just 3x. And 1 times 1 is 1, and that simplifies to 3x. Number 12. X plus 3 over 3x divided by x squared minus 9 over 9x squared. What are we doing? We're dividing fractions. When we divide fractions, we multiply times the reciprocal of the second fraction. So we leave this one alone, and we multiply by the reciprocal, the refliprical of the second one. Okay, so what do I get when I multiply? Now I went from dividing to multiply, so now I'm going to multiply straight across. So I got x plus 3 times, I'm going to put it in parentheses because that's a factor, that's a package deal, times 9x squared. And I have 3 times, I see right now 3 times this is dots. And when you factor dots, you get sum and difference. So I'm going to go ahead and break that, factor it right now, break it apart. So let's go back. I still have x plus 3 times 9x squared, and I still have 3 times, and instead of writing x squared minus 9, I went ahead and factored it, and I got x plus 3, x minus 3. This is still x squared minus 9 when you multiply those two binomials back together. Now, I see this. This is a monomial. There's no addition or subtraction. So I'm just going to factor it like this. And I have a monomial factor here, and I have a binomial factor here. Well, I've a factor of 3 in the numerator and denominator that I can cancel out. I can't cancel this x out with this x because this is a binomial. It's a package deal. This entire thing is a factor. So I'm left with 3x squared over x minus 3. Number 13, 7d to the 5th over 4 divided by 7d to the 3rd over 12. I am dividing fractions, so I'm going to multiply times the reciprocal of the second fraction. So I'm going to rewrite it. Instead of division now, I'm going to multiply by the reciprocal of this second fraction. You know what makes this really sweet? Monomial, 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 monomial. No addition or subtraction. I can just slice and dice these babies apart. Now, this is 12 right here. There's my 12. There's my 7d to the 5th times 12. Why did I make 12 3 times 4? How come I didn't make it 6 times 2? I could have, but look at, there's a 4 down here. So if I have a 4 up here, then that means I can cancel those 4's out. Now I could call this 2 times 6, and I could call this 2 times 2, and I could cancel out my 2's, but then there'd still be some more canceling to do. So